Bon a locale, bon a locale. I do not have the chat window open yet, so I don't see if anyone's here right now. There we go. I guess I'm just kind of talking to myself for a minute while I get stuff set up. I've already sent the message out to social media and Discord, and I think everyone's got it, although honestly I don't suspect my programming streams are going to be my most popular option these days. Yeah, well, let's just wait for people to show up and get a few things set up and running. Let's run Visual Studio Code. Close off anything that is... I don't need that open. Go away, you. Huh. Rather quiet this morning. I'm used to seeing people within the first couple minutes. Oh, wait. Suddenly, a big jump in users. It went from 0 to 1. Bon locale, where's my chat window? There you are. Hello, Gypsy Guerra, how are you doing? We're gonna be doing a pretty geeky stream today. I'm just... well, mostly I want to be spending time discussing some concepts in programming, because the logical structures that are used are so broadly applied throughout all of programming. I find it extremely important. Oh yes, I heard about that, Neeboop. Yeah. Although something I found more interesting is the number of news outlets who are actually covering the sex trafficking and sex cults in America right now. God damn it. Why isn't my camera working? Deactivate and reactivate. There we are. Alright, so hello everyone. But yes, there have been some news articles that came out recently discussing the fact that the entire Flynn case has been passed up to Congress, and there is an extremely strong chance he's going to be, well, vindicated, to put it very simply. I'm very happy to hear that, because, well, let's face it, we all knew he wasn't guilty of lying to the FBI. He just admitted to it because he didn't have another option. He was basically stuck between a rock and a hard place, and creating jeopardy for high-ranking members of the United States administrations is just dark, to put it simply. I need to move you over here just so you're not in the way. Take care. Have a good day at work, Neeboop. And I need to... I guess I can just... I want to wait until some more people show up so that people aren't missing the introduction, because with these programming streams, it's a little more detailed, a little more involved. You don't want people missing the beginning, because then they're missing important information. But I guess I can just start rolling with it, either way. Pence really did set him up. I guess we can take a moment and look at some of these stories, because there are some pretty fucking good stories to look at. The big sex cult in the news today is NXIVM, whom Senator Kristen Gillibrand has direct connections to. Let me put this on screen for you guys. Just gonna pop up my desktop because I don't care. Yeah, so NXIVM, devotees of the upstate self-help organization pay thousands of dollars for seminars, wear colored sashes to denote their rank, spout Scientology-like jargon, and literally bow their head before leader Keith Raniere, whom they call the Vanguard. NXIVM has deep pockets, outposts around the world, and draws celebrity attendees, including billionaire Richard Branson and actress Allison Mack, Kristen Kruk, and Nikki Klein, and even hosted the Dalai Lama at an event in 2009. But behind the scenes, Rainier has been blackmailing his female followers into becoming sex slaves branded with his initials, while other women in the group were made to wear fake cow udders on their bare breasts in acts of ritual humiliation, federal prosecutors allege. Now, of course, they're focusing on this part because, oh, the poor women, but it's not just the women who are suffering. The men are pretty routinely ritually humiliated as well, and it's pretty fucking horrific. But it's not just a matter of this cult. It's the fact that our senators are directly connected to this cult as well. Because Christian Gillibrand, who of recent Me Too fame, has direct connections to the cult. She hired the lobbyist for NXIVM, as well as Keith Rainier, her father was a lobbyist for the group, and she is right there in the midst of all of it. As much as she tries to deny it, the money trail is coming out. It's pretty fucking hilarious if you ask me, because we're starting to see these cults, these disturbing cults within our country come to light. And it's not just this cult, because we've got, hold on, let me find that link again. Where is, yeah. Everyone is talking about the child sex trade in the US, and for those of you who've been around, you know that this is a very personal subject for me. The child sex trafficking market is resulting in more than 1 million children abused around the world each year. So how has the market proliferated? Tim Sorenz, a columnist and editor for Indianapolis Star, recently began publishing a series of articles about the sex trade, a subject he's reportedly investigated for more than a year. He explains that the child sex trade is like any other business trade, driven by supply and demand. According to a study by the Center for Court Innovation from 2016, between 8,900 and 10,500 children aged 13 to 17 are sold in the U.S. each year. Swarens writes, the researchers found that the average age of victims is 15 and that each child is purchased on average 5.4 times per day. To determine a conservative estimate of demand, Swarens multiplied the lower number of victims identified in the CCI study by the rate of daily exploitation, and then by an average of only 1 workday per week, 52. The result? Adults purchase children for sex at least 2.5 million times a year in the United States, and that's a remarkably conservative analysis. Oh, people are starting to show up. Wonderful. Hello, Kaho-chan. I'm so happy to see you. And, yeah. The rest of this article goes on. Now, they say, why are these men buying children to abuse? But it's important to note that women buy children to abuse as well. It's not a primarily male audience. It's everyone. Well, not everyone, but all demographics seem to involve themselves in this trade. While more often than not, the women involved are more in it for physically and psychologically abusing people. They are still involved, and they're getting what they want out of it. But now that people are starting to show up, I can actually start doing the intro to the programming part of the stream, because that seems like a good idea. Thank you all for showing up. I just wanted to talk about something I found fascinating in the news recently, because, I mean, even just the day before yesterday, we were getting no stories about the human trafficking and child trafficking, and now it's all coming to light. but I'm going to wait a day before I actually do a stream on that subject, a full stream, because I want all of these stories to hit the cycle before I do it. I want as much information as possible. Instead, today we're going to be discussing programming again. There was requests by my patrons to do another programming stream, and instead of sitting down and trying to program an entire application in 2 hours, which is insanity, I'm much better off finding the time to do like a 24-hour programming stream at some point. I would gladly do that. Hello, Celtic Rune Singer. So glad to see you. How do I keep mispronouncing that? I'm such an idiot. I wanted to discuss some concepts in programming first because, well, honestly, programming has a long history of just pure research, and that's what fascinates me about it. You can find book after book, after document after document, after publication after publication, after request for comments after request for comments on different subjects in programming. And if there's any subject which has an extremely condensed but pervasive research history, it's programming. Whereas math took hundreds of years to reach the point where it is right now, in the span of about 50 years, programming went from pure machine languages and lambda calculus languages all the way up to where we are now with full-featured tool chains, compilers and transpilers, all sorts of things. And it's all because all of this information is so freely available. If you want to read a book on programming, you can go to O'Reilly's website and sign up for $5 a month and read their entire library. If you want to... excuse me, I'm sorry. Oh, fucking microphone. But if you don't want to pay that $5, you can Google... If you can find the name of a specific subject, such as a specific programming pattern or a programming language and a concept within that programming language, here, let me show you. Let me drag out a new tab over here. Let me center that because I'm anal retentive. Let's go with JavaScript Deep Learning. And look at that, we have a library right at the first link, at which we can play around with something, but we also have entire tutorials, training for machine learning beginners. And entire tutorials show up. We can find port TensorFlow models, for those who don't know. TensorFlow is a very specific... No, that's not what I wanted. TensorFlow. TensorFlow is an open source machine learning framework for everyone, and it has been ported to, like, every language. It essentially allows you to do numerical computation using data flow graphs. It's linear algebra for AI, essentially. Right? Let's say you wanted to find another subject, and yes, I'm using Google. When it comes to doing my live stuff, I have my Google accounts. A lot of people have commented on the fact that I tend to use, the same account name in all different places, which is poor operational security. Well, you guys only know about my public persona, and that public persona is specifically for the purpose in broadcasting and sharing information. So that's why I use this. I've got a completely different suite of tools for things I want to do privately. But, well, speaking of private, let's go to Golang and IPFS. Go is a language produced by Google, which is a compiled programming language which uses a very strict coding style or style language, or not style language, what's the word? Just standards. It uses very specific standards, well, as much as I don't use it, there are a lot of impressive things built in Go, including the IPFS base libraries and application. IPFS, of course, is probably the future of file sharing. It's very likely the future of file sharing. It's a global versioned peer-to-peer file system in which you can share files using a very basic string. Do they have an example on this page? No, of course they don't. Oh, nope, they do. All right, so using a hash like this that starts with QM, it basically creates a globally and even internationally, not internationally, but like it's designed to be able to transfer files from one planet to another. That's the theory behind it. And like this, you can also find Golang design patterns. Now, what are design patterns, you might ask? Well, design patterns are a concept that originated in the early 90s when programming languages started to get more complex. There was a group of programmers who called themselves the Gang of Four. And this Gang of Four wrote a book called Design Patterns, Elements of Reusable Object-Oriented Software. Now, this wasn't wholly revolutionary. All of these patterns had been used for years before in C++, in the early forms of Java, they weren't really used in COBOL. They're mostly oriented towards object-oriented development, and honestly, these are the kinds of things that you learn in college when you're programming. The Gang of Four is a fascinating group of programmers: Eric Gamma, Richard Helm, Ralph Johnson, and John Vlissides, and they've produced this book that was extremely... It's as commonly used and referenced as the old C++ Bible was referenced, and to this day, students learn things that were originally taught back in '94. Now, this is the beauty of programming, is that so little of what was figured out even 20, 30, 50 years ago is still applicable to this day. These patterns make it extremely simple to produce code that accomplishes otherwise complex problems. Now, what kind of problems am I talking about? Well, specifically programming problems. And sorry, I keep looking over here. I've got all sorts of shit spread out on my desktop right now. And I've got my OBS over here, so I need to, whenever I'm switching back and forth, I need to use that. So the basic idea of a programming pattern, or a design pattern as it's called, is that you can use this to accomplish a specific goal. There are a number of design patterns that are split up into three categories, at least at least as far as the original Gang of Four book arranges them. Since then, numerous programming patterns have come to light, and this list has extended to more than 100 different possible patterns to use. But the core design patterns, the original 23, are still in common use today and applied wherever they are most useful, especially things like the structural patterns, the adapter pattern, the composite pattern, the decorator pattern, and I'll explain what each of these things are as we get to it. But let's start with a simple concept. We've talked a lot about blockchains in my programming streams, and one of the most interesting things about blockchains is that it, in and of itself, is a programming pattern. The idea of creating an object or a class that not only produces its own object, but references all previous objects using the hash of the previous objects inside of them, and creating a system by which the latest block, excuse me, I don't know why my hiccups are acting up. Let me grab something to drink right quick. That each block that is created has the tools within it to create the next block. This is something I showed off in my last programming stream. And there are even simpler ways to do it, in which you don't actually create a blockchain class. You instead just create the block class, and the block class has a method on it which will use the current hash to prepare the next block, and then the next block can be validated in any means. But what if you want a blockchain that, or rather, what if you want multiple different types of blockchains that don't fall into a precise pattern? What if you have what if you've designed multiple blockchains, like, here, let's get some code going. Make-dir design patterns and blockchain. Yarn and knits. Come on, hurry up. Thank you. Yarn add dev babel core babel cli babel preset env. I don't really need anything else. I just need my basic tools, and we're going to grab those while I'm talking. Okay, let's say you want to create a blockchain for a diary, for example. You want to assure that no one is editing or changing previous entries in your diary, and that this information remains completely secured. It's the data within it is validated and continually validated up the chain, so that you always can be sure that this is your writings. I know it's kind of a weird example to work with, but honestly, when it comes to making simple examples, weird examples are what you get. Is this the one I liked? Yes. Now, there was a mega simple blockchain sample I was going to use to start working on this. Make-dir source, make-dir lib, code source blockchain.js. Now, we're not using a linter, we're not using a test framework, we are just doing example code here. So if things go wrong, I'm just going to skip ahead instead of spending all of my energy trying to debug a teeny tiny little problem or fit with a style guide for the programming language. But essentially what we're going to do is create a super fucking simple blockchain. Class block constructor index data previous hash. This dot index equals index. This dot data equals data. this dot previous hash. I need to. I keep doing this. I keep mixing up the ways that I do common. This dot timestamp equals date dot. Is it date dot now? Or is it date dot get time? JavaScript dates. I believe it's date dot now. It's pretty fucking common. Date dot now or date dot get time? Oh, that's what it is. It's date dot now dot get time. And finally, we need to create our hash, which is going to be this dot hash equals this dot calc hash. And then we need to calculate our hash, so calc hash. Shit, I don't have a yarn adds crypto.js. I need to add in an import crypto.js from crypto.js. And crypto.js is of course just our encryption and hashing library. Crypto.js. I'm looking for my documentation on it so that I have it on hand. Well, we'll just go simple. We'll just go simple for now. Calc hash return crypto.js dot SHA-256. I believe that's it. Is it? It might be lowercase. Frustratingly enough, this documentation sucks. And my memory is so horrible that I very often just forget things. So I can look into the tests for this library, yet another effective way of doing things. See, yeah, okay, it is. So return crypto.js.SHA-256. I can use template strings. This dot index. This dot timestamp. This dot previous, no, well, data to JSON.stringify this dot data and this dot previous hash to string. And that will give us our extremely simple hash. And of course, we're just setting this up right now, so JavaScript, well, you see, ES6, static methods. Static members in ES6. Yes, okay, so now we can just do static first. Which will create our Genesis block. Data equals... can I do it like this? I believe I can. I don't need that space there. Data equals... Actually, I guess the consistency doesn't actually have to be there. Genesis. And we are going to create a return new block 0 data 0. Now, I'm not entirely sure that this is going to work correctly, but the general idea is there. And then static next is going to be previous and data equals, and then the default is going to be contents of blog or diary page. And then we return new block previous dot index +1 data and previous dot hash. And of course, this will essentially just create a new block using the data of the previous block. Unfortunately, this is a very cheap way of doing it. We could always... and essentially what we're doing here is this allows us to do genesis, or const genesis equals new block dot firsts, and then const second block equals block dot next genesis. Today I did a stream. And if I did this correctly, I should be able to Babel node npx Babel node source blockchain.js unexpected token. Oh, right. Babel RC. I need to add a Babel RC. So presets env. And it might bitch about that, but whatever. Save and try that again. Date now get time isn't a function. That's odd. Sorry, just a second. JavaScript date get time. It is... yeah, it should work. Because date.now should return a new whatchamahoozer. Date now get time. Oh, I guess I can just do date.get time because the optional. Okay. So I did not need the now in there. Save. And logically, okay, now date.getTime is not a function, you liar. You are so full of shit. I know it's a function. Oh, I'm an idiot. New date. I'm an idiot. There we go. Let's move on to the next, and nothing happens. So now if we console.log second block dot previous hash and console.log second block dot data, we will get an output of the hash of our Genesis block, which is here, as well as the contents of our second block, which is today I did a stream. This is an extremely simple format. But this allows us to start playing around with the concepts. So let's say we wanted to make our data use a specific format, right? Right now, our data is just a string of text. But what if we wanted to use something more complex, like the different fields that one uses in a blog? Well, we could create an entirely new class based on block and change the way data works. Or we could... I'm sorry, I just saw the chats. Hello, Curated Opinions. Hello, Atakeen, and hello, Aki. And it's not so much hiding an identifier that can't be falsified. It's creating an identifier that can't be falsified, because every time you create a new block, it is hashing. It's kind of weird to explain. So we created our first block. Our first block created a hash of this data, right? So let me babel npx babel node. Let's bring up a console. Var const crypto.js equals require crypto.js and const, oh well, let data equal boobies. Alright, so if we do this, crypto.js.sha256 data to string, we get a hash string, right? But what happens if we change data to boobies with 0? Why am I using boobies? Because I don't know. It was the first thing that came to mind. Now, if we do this again, these two strings are completely different, right? The hash of that data produces a completely different SHA-256 string. Now, let's create a second data. Let data2 equal show bobs. And let enc data equals boobies. Let's set it back to the original one. And let encrypted data2 equals crypto.js.sha256 data plus encrypted. I gotta do encrypted data. Let encrypted data equal crypto.js.sha256 data to string. Let encrypted data 2 equal crypto.js.sha256 data plus, or excuse me, data 2 plus encrypted data to string. Encrypted data 2 is now this, but this is entirely based on the consistency of data being the same, because we included this encrypted string in our encryption of the one-way encryption of the next string. So if we make a change to boobies, data equals boobies, and then re-encrypt, and then re-encrypt our data 2, we have a completely different string here because the data from the old encryption has changed. See what I'm saying? This form of one-way hashing is extremely effective for essentially fingerprinting your data. It creates a fingerprint, and then you can include that fingerprint into your next bit of data so that the fingerprint is based on all the previous fingerprints. Does that make sense? It's extremely valuable. It is extremely useful, especially in medical fields, is one of the places where this kind of repeated fingerprinting allows you to assure that none of the data has ever changed from point A to point B. A common example would be creating a heartbeat monitor, which would actually be extremely simple with blockchain. In fact, instead of making a blog, let's use our data. Let's use design patterns to create a abstract factory. I believe it's abstract factory. Yes. That is actually a really shitty implementation of that design pattern. Abstract factory. So let's talk about this design pattern right quick. What we want to do is essentially create an abstract block. A block that doesn't actually care what kind of data it has in it, but rather produces a block of this type that is specific to the data we want to use, right? So coming down here, we have our raw block here, and I'm going to change this to 0, a string of 0, because, yeah. And then this is going to be empty, an empty string. Now, most of this code can already be used abstractly, but what we want to do is abstract a little further. So what we're going to do is create an abstract class, a factory that arranges the data for us and assures that our contents are what we desire them to be. Now, in JavaScript, all classes are just a form of objects. So you don't have a distinct type of abstract class separate from a regular class. So you can just do something like class abstract block destructor index data previous hash, and you can move all of this into here, and we're going to delete that for now, and then create class beat per minute block, which allows us to oh shit, I forgot to extend abstract block. And this will allow us to do constructor index data equals heart rate 0. Uh-oh, looks like our patient's dead. Previous hash. And then we call super, which essentially just calls this constructor from the abstract block, because this is our super. The class that supersedes our class in setup. And then from here, we don't actually have to make any changes right now, right there. However, we do want to make changes to the way, actually CalCache will work this way as well. However, we do want to make changes to the way static first data equals heart rate 0, return new block 0 data 0, and static next previous data equals heart rate 0. Now, do we need to call super on all of these? I don't think we do. No, we don't. Return new block previous dot index plus 1 data previous dot hash. And now we can do this. We can create a class, BPM client, which constructor doesn't take any information off the bat, but what it does is this dot blockchain equals I think I messed something up. I did. I forgot to do one thing in our abstract block. We need to add a static get instance, which always returns return new BPM block. Wait, do we need to return a new BPM block? I'm sorry. Forgive me, I'm confusing myself just a little bit. And unfortunately, this static get instance is being declared before BPM block exists. Frustrating. Circular references are a problem, unfortunately. Let's see. No, wait, they should be elevated, because classes are literally just functions. So, yeah, we return new... Do we want to return new or first? I think we return first. BPM block dot first 0 heart rate 60 0. Or rather, we just need heart rate in there. And now our BPM client now creates a wait, I'm sorry. Right, so our BPM client creates a new instance, const BPM block instance equals abstract block dot get instance, and now we have the start of a blockchain. And we can then tell BPM clients to use any instance, and of course, we could do this with anything. We could set up a list switch type equals BPM switch type case BPM break defaults return abstract block dot first with no text in there. Alright, and now we can change this up so that what we have here is BPM client, create next block data. And what this is going to do is allow us to basically abstract out and create as many of these blocks, as many of these custom blocks as we want, and then we add them to our get instance, and we can just create our blocks using what is called essentially what is called a factory, a system that can spit out whatever kind of block we want, and we then const next block equals this dot blockchain this dot blockchain dot length minus 1, which will give us the last block in the chain, dot next with actually I should probably clean this up a little bit. Prev block equals this dot blockchain dot length minus 1, and const next block equals this dot blockchain, excuse me, prev block dot next prev block, and oh wait, no, that's static, so I fucked this up a little bit, but it'll work nonetheless. No, I need the actual class. That's weird. Something I'm gonna have to look into, but this will still work nonetheless. Prev block data. This dot blockchain dot push next block. Now push basically adds a new entry into at the end of a list. So by having these little square braces around this, we've essentially said we want a list with the only entry being BPM block instance. And of course that creates the Genesis block here. And then we use that Genesis block, which is currently named next block, to create our next block. So let's play around with this. Now we go with BPM client dot or new BPM client get instance, yeah, is using first, so it'll automatically do all that stuff. We create our new BPM client data, and it's going to use the flat data, and then we go with second block equals Genesis dot create next block heart rate 45. Now we can we don't actually need to tell it to do this because BPM chain and BPM chain. Now we can go in here and say we want to see BPM chain blockchain BPM chain dot blockchain dot length minus 1 dot data, or well, hash. And then we want to also see BPM chain dot blockchain BPM chain dot blockchain dot length minus 1 dot data dot and now block is not defined. Where did I use block? Oh, that's where I used block. BPM block and BPM block. Yeah, abstract block and abstract block. Do I need it anywhere else? Nope. Alright, and now we run it again. Previous block.next is not a function. Of course it's not. Shit. That's odd. Let's, do it like this. BPM. It's still gonna throw an error when I do this. However... wait. Hold on. I know what to look for. I know what the problem is. I'm passing the object. I need the actual class. Return class, C... or ES6. I know I can return a class. I know I can return the actual class. It's not... No. Here we go. It is... How do I return the literal for the class? Come on, I know... I know I can do it. I know I can. Oh, get prototype of. Duh. Where is it? Get instance. And I'm gonna have to make some changes elsewhere to make this work. Although, why is it being so bitchy? Yeah, I should be able to just return it like that. I don't know why it's complaining. But yeah. So now in our BPM client, dot first, and then from here we go to this dot BPM block instance. And we end up with a far different bug. BPM block instance is not defined. On what line? Line 52? Oh, right, this dot. I'm an idiot. And there we go, except for the whole undefined parts, which shouldn't be undefined at all. Did I not put data in the... I did. Yeah, BPM chain, create next block with data of heart rate 45. Why is that undefined? That's weird. But yeah, what we're doing here is we're creating an abstract factory. So we have our abstract here, right? This basically defines the way any class that inherits from it is supposed to be used. Now you can add to it, but you can't remove from it, because these are the expectations that our class has. Here we're creating a we're creating an instance or a non-abstract class which tracks beats per minute. And yes, there's a bug with it, but for educational purposes this will work well enough. And what we're doing is, instead of using a flat empty string for our data, we are instead using an object which defines the heart rates. And then we have a client which makes use of our abstract factory, because we know what kind we want, but we don't want to call it directly. We want to be able to create perhaps multiple different types we want to be able to create multiple different types of objects for the sake of our BPM clients. And as such, we don't need to know the actual class. We just need to know where it comes from, right? So we can create any number of children of abstract block without knowing if they exist. And if they don't exist, that's what this section is right here, we just give them the bare bones abstract block, which will still do what they expect, but won't have any bells and whistles like BPM block does by defining its core data. And this is a common programming pattern. This is how you can... gaming uses this a lot, for example. Let's say you want to create an object in the scene, and I'm going to switch over to the camera right quick. Let's say you want to place an object in the scene. You don't want to have to memorize, all the differences between an enemy object, or a player object, or a background object, or etc., etc., etc. You need to be able to just say, I have an object, it has a type, what you do with this type is up to you, but here is the data I need, because I just need the core object, functionality to get to it. Now, why am I showing you this? Well, simply put, this code actually works towards something I intend to make soon. I want to be able to create abstract blocks on the fly. Now, while this pattern works, it's not perfect. One, as you saw, we basically had to define our types in getInstance in a switch statement that will check type and then determine which class to use, falling back to its default if nothing else works. However, there are other design patterns which actually work a lot more efficiently than this for this purpose. For example, there's the prototype pattern. If an object has certain properties, we can use this to create an object that will use those properties. Essentially, we can take an existing object and then prototype based on that, instead of prototyping based on the core class. There's also the factory method pattern, which is a very simplified form of this, in which instead of having an entire client, you just have a function that will return. Essentially, this here, our constructor for BPM client, is a factory method in and of itself, because all it's doing is making use of an abstract class and building based on the factory defaults, essentially BPM, the objects that we need. You've also got the builder pattern, which instead of taking a single prototype, can actually reference multiple prototypes and assemble them together into a single class or object for that matter. Again, these are things that get used in gaming all the time. But these are just ways to construct data. What if you need to structure your data more in a more detailed manner? Well, blockchains already use one of these offhand, and that is the, where is it? Where is my, blah, 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 observer pattern. So an observer is essentially an object or a function that sits around and watches other objects if they change, right? So on the subject of blockchain again, the way a complex blockchain works is that after you've created a block, you actually have to go through and validate that block against every block that came before it. And if you have the longest chain of blocks, then you're okay. This is accomplished by an observer. Well, somewhat of an observer. It's a function that once it knows it has new data, goes through and runs validation on itself and everything that came before it. I didn't need to switch over to the camera. By the way, hello Ghost Dog, welcome to the show. I'm probably not going to be going for super long today. I'm mostly just discussing concepts in programming that are extremely useful. Now, observers are pretty complex. They're fascinating because they're used everywhere. JavaScript is filled to the brim with observers. Situations like having an event emitter and event receiver, that's an observer pattern, because you have code that will broadcast an event, much in the same way that a blockchain will broadcast, hey, I've got a new block, let's validate this chain against your chains to see if we're doing okay. And in doing so, essentially creates a situation where every node in the blockchain network becomes an observer of every other node in the blockchain network. You've also got things like, you've also got much more complex patterns, like the strategy pattern, in which you have a family of algorithms, but you don't want the programmer to have to decide which algorithm they need to use. Instead, because based on the data, you can break down the code. You can break down what algorithm is actually necessary. Now, do I have a good example of the state pattern or the strategy pattern in JavaScript on hand? I'm not sure I do. Behavioral, I do. Interesting. So, essentially what you do is you create functions or classes which follow specific rules. Like, let's go the very simplest. You've got a shopping cart, right? And you need a strategy to determine whether a user is going to get a discount or not. So this, so what you do is you create your shopping cart, you create a bunch of functions that define each of the different strategies. Like the regular strategy is that the price is going to just be the basic price. But then you've got like premium users who get a discount. So you've got a separate function which says, okay, we're going to take the amount and multiply it by 0.9. In other words, shaving 10% off of the price. And then when it comes time to calculate your charges, you then where's discount? Oh, you then take the function that was passed into your instance of the shopping cart and apply that to the price. I mean, this is actually extremely simple. Let me give you a very, very bare bones example to see if I can explain this better for y'all. Let's code source shoppingcart.js. Let's create 3 strategies. Const default strategy, amounts, return amount times 0.9 amounts, and then const premium user strategy equals amounts, return amount times 0.9. Now we create a class, shopping carts, which constructor only takes a price strategy. This dot, well, I guess we'll just, for simplicity's sake, we'll call it discounter. This dot discounter equals discounter. This dot amount equals, let's say you're spending $20. Yeah. Checkout will then return this dot discounter, this dot amount. In other words, we are going to return the value of the amount after applying the premium strategy, if we have the premium strategy in there. And then set amounts is this dot amount equals amounts. Let's set that to 0 for now so that I can show off the actual flow of operations. Now, const new cart equals new shopping carts, which uses the premium user strategy. Cart dot set amount equals, or set amount to $20, and console.log cart.checkouts. So npx babel node source shoppingcart.js. It should be pretty. Don't be a dick. Where am I missing a bloody semicolon? How am I missing a semicolon? Oh, return a typo. And of course, because we gave a 10% discount, our price is $18. And that is an extremely simple version of the strategy pattern. And the strategy pattern is a place where you can actually use the abstract factory to assure that you can just say, look, user is a premium user, give me the premium user strategy. hello, Cube. I didn't see you come in. How you doing? But yeah, so this is essentially an extremely bare bones example of what the strategy pattern does. And what you're seeing here is, what I'm trying to show you essentially is that there are just things that you have to do very frequently when you're programming. You need to be able to declare that there are different ways and different algorithms that will be called. You need to say that this is a parent of all other types of objects that come below it, and I don't need to know what comes below it. I just need to access my data in the common manner in which all of these objects share, and you can handle the rest. These are processes that create very clean, very straightforward application programming interfaces, or APIs, so that your user doesn't have to worry about what's going on under the hood. This is a big concept in programming, and it's only about 30 years old. Before the early 90s, you had to know every bit of code that was going on inside the code you're using if you wanted to use it. And programmers in the early 90s said, look, I don't want to have to know every step that's being taken under the hood. I just want to use your code, and I want to use it in a sensible manner. And this is where the Gang of Four's design patterns became such a huge hit. Now, there are a ton of design patterns available. As I mentioned from beginning, we have the three categories: creational, structural, and behavioral, with the creation patterns being abstract factory, builder, factory, prototype, and singleton. Now, singleton's actually quite interesting in that essentially you will always get the one object you created back, even if you create new ones. So as soon as you create one object, that object is globally tied to the class. And there are people who say that this is not a good way to do things, but it's a way to do things nonetheless. That way, whenever you, like, let's say you've got multiple functions, and all of them need access to a centralized state. A centralized bit of data, like a blockchain, a specific blockchain within an application that allows you to share this information broadly. You need to share it all across your application, and you don't want to just stick a variable in the top because anyone can change that variable. You want functions and getters and setters to control the flow of data. So you create a singleton, and that singleton will always return the same object instead of returning a new one every time. And that same object can be used to read the information, and a common use for this is like config files. You create a singleton of the config so that you don't have to translate the configuration every time you load it up. It's loaded up once, it's stored in a place, and from that place you can always access it and get the same information. Singletons are a very controversial subject in programming because they parallel with globals, and global variables are considered dangerous because they can be changed at any point. LT, how are you farting like this? I took you out this morning. I took you to the bathroom. I'm sorry, my dog is gassing me again. Now, in the structural patterns, we have our adapters, our bridges. A bridge is essentially a system that allows you to access methods and data from another class as if they were within the class you're using, usually by having actually our strategy class uses a very minimalist version of a bridge in which we take a function that's defined elsewhere and set it as a function on the instance of the shopping cart class itself. A composite is where you take two classes and basically declare them to be one. It's at runtime rather than creation time. So let's say you have, to bring up our gaming examples, let's say you've got a player object. Once that player object is created, if you need to add to it to make sure that it also behaves like an enemy when you're not pushing any keys. Take a game like League of Legends or Dota, for instance. You essentially composite. You create, after you've created the player, you then composite that specific player object with the enemy object and have a system of strategies on when and where to use the different strategies. You've got the decorator pattern, which allows you to very quickly add in details from other sources. Like decorators are pretty commonly used. They're essentially you've got an operation that you need called, right? When the function is called. So the function runs itself, but when the function runs itself, it's actually running in an instance of our decorator, which then makes changes and extends the results of the called function. You've got facades, which basically can act like a different class depending how you use it. You've got flyweights, and flyweights they're not commonly used, but essentially what they do is it allows you to create an extremely lightweight collection of all of the objects that have been created from one or more classes. And then you've got the proxy, which is essentially if a request is made to, if you want to, networking is a great place where proxy patterns are used commonly. If you want to take your data and keep it somewhere safe, and instead of allowing it to be accessed directly by any other code in the system, you create a proxy that can validate requests and then pass those requests on to the object for which it's proxying. And then you have the behavioral patterns, which are all strategic patterns, honestly. You've got the chain of responsibility, which essentially handles requests and then passes the request on to the next person, the next object in a chain of responsibility. You've got the command class, in which you have entire objects dedicated to executing specific commands, running entire sets of strategies, and you just pass it an instruction like you say object.run operation 1, and then it will go out, it will build the receiver for the commands, and then it will execute that command for you instead of calling the object directly. And there are so many of these things. There's the interpreter. Interpreters are extremely common in programming languages themselves because that is essentially what a programming language does. The compiler, or the interpreter, as it's called, takes the text of your code and then goes through it step by step, token by token as it's called, and interprets what is actually necessary, what is actually being requested to be done here. Iterators are a very simple behavioral pattern in which you can step forward or back on a list, and this is another place where blockchains make use of very old design patterns. Because, for example, in my blockchain example I showed you earlier, there was a next function, and that next function creates the next block. However, we could do it that, we could set it that if we called next on a block that already has a block following it, it would just return that existing block. And if we called previous, it would find the block that has the previous hash that we passed to that current block. There's the mediator, there's the memento. Memento is essentially create a memory of how an object was at a certain point, usually before a function is called that's going to change it. You've got the observer, which I've explained. State is fascinating. State functions, or state patterns are used everywhere because you have to look at what the data is looking like at that point. Flowcharts. All flowcharts are basically simplified versions of state patterns because you're taking the state of an operation and then determining which branch you're going to go down next based on that state. And then from there, you are then making another decision from what branch you're going to take based on that state. We discussed strategy, and then there's templates, visitors, dozens more. But one programming pattern, and the reason that I'm doing this stream, that is going to just... it's going to change the way that we handle data tremendously, is the blockchain pattern. And of course, at the very beginning of this stream, I showed you the blockchain pattern in its most simple form. A teeny tiny, simple little function, or class rather, that sets up its data structure, calculates a hash, takes a previous hash, and then hashes all that data together to create a fingerprint, and assure that nothing is falsified or changed in the past, so that we can assure that the data we have at the tip of the present is going to be exactly what we want it to be as soon as someone adds more to our chain. That was a lot to discuss, and I know that I was probably just firing bullets over everyone's head, but these are things that I needed to talk about and explain before I could get to explaining some more complex stuff. My next programming stream, which I haven't really planned a date for yet, but we're going to be doing a much longer show. I don't think I can actually accomplish a full 24 hours of programming stream. As much as I would absolutely love a day of programming stream where I just sit down for 24 hours, hang out with you guys, and program, there's just too much chaos and noise that goes on in the background, and to do that would be a tax on the people I live with as well. But I think instead what I'm going to do is split it up into split it up across a week, in which I actually sit down for about let's see, I think I can do 6 hours. I mean, like, I'm gonna have to take breaks, of course, but a 6-hour stream, and I might do this for next week. When is the 1st? Oh, the 1st is this Thursday, so I'm not sure yet. Definitely gonna need a case of energy drinks. If you guys want to donate for that, please do. I'm thinking that April 5th to April... Oh no, April 2nd to April 6th would be a great time for me to do this. Yeah, I mean, if you guys want that, I would love to sit down and basically do 6 hours of straight programming, in which I'm not so much trying to explain in depth as I am trying to show you guys a project coming to fruition, warts, bugs, and all. And the project that I want to create is essentially an abstract blockchain, which can be used to create any kind of necessary data that an individual would want. Now, we're not creating a blockchain in the cryptocurrency sense. We are creating data that is verifiable data that is also can also be decentralized and distributed amongst several, computers, including, now, I mean, like most people, they have like a laptop, a phone, and a work computer, right? You could essentially, what I want to create is an application or a web app probably, that you can run on your phone, you can run on your laptop, you can run on your desktop machine, and you can run on your work computer. And all of these will remain synchronized through the blockchain communication system. And why I'm doing that, I'm going to have to save for next time, because for right now, I really need to take a rest. I did not really sleep last night, but I really did want to make sure I streamed for you guys. There were a lot of requests for programming streamed today, and you know what? I'm glad I did, because this is stuff that is very integral to who I am. I mean, before anything else that happened to me, as a very young child, this is the shit I was studying. I was reading the Gang of Four's design patterns at 10 years old. I was reading the source code to Linux at 12 years old. At 13 years old, I was decompiling the AOL application using disassemblers just to see how they created such a, well, shitty application. And it's these patterns that have really influenced who I am as a programmer, as an entertainer, as everything I am. I'm always looking for these structural, behavioral, and compositional patterns that exist in the world, and trying to distill how this can be turned into a loose and simple abstract. Now, I hope you go out and read the Gang of Four's design patterns, which is available freely online. You can torrent it, you can pirate it, or if you absolutely want to, you can buy it. But, I mean, you are talking to me, and I haven't bought a book in my life. I've only ever gone to the library or gone to the torrent sites. So, do what you will with that. But yeah, with that, I'm going to wish you all a wonderful evening, and I hope you research further into these subjects, both blockchains and design patterns, because once you start noticing them, you can see them everywhere in the applications you're using. You can even see them in the operating system that you're using. You can see them in the games that you're using. And having this this integral understanding of how programs work on a very base level will allow you to make much clearer judgments about why an application is having problems. Because let's face it, no program, no application is ever going to be perfect. But if you don't know what's going on under the hood, if you can't make presumptions about what's going on under the hood, you'll never actually understand what's gone wrong. You'll never actually be able to make educated guesses about why something went horribly. And with that, I wish you all a wonderful day. Take care.